with the next session of Strength of Materials. In this session, we'll discuss a numerical on Euler's limitation. What is the minimum actual length of the column for which Euler's formula hold good if the cross-section of uniform column is a square of side 150 mm? The first data that is given to me is the value of side. Say I call it as A, it is given as 150 mm. The column has one end hinged and the other end is fixed. So one end hinged and other end fixed. For this, my LE will be L by root 2. This is the fourth case that we have discussed. Take sigma C as 250 megapascal. That is, it is 250 Newton per mm square, and the value of E is given as 200 gigapascal. That is 2 into 10 raised to 5 Newton per mm square. So I am supposed to find the minimum actual length, that is the value of L, for which Euler's formula will hold good. Now, we know for a square, calculating area is very simple. It will be side square, that is 150 square, that is 22500 mm square. And I'll calculate the moment of inertia for this. That will be A raised to 4 upon 12. This is 150 raised to 4 upon 12, which will be 42.1875 into 10 raised to 6 mm raised to 4. Also, let's calculate the value of K, that is root of I by A, because we have just calculated both. So when you take the square root of this ratio, you will get the value as 43.3 mm. So I have done the basic calculation. Now we know for limitation of Euler's formula, LE upon K min should be greater than equal to pi root of E upon sigma C. LE I do not know. K minimum I just found as 43.3 should be greater than equal to pi root of 2 into 10 raised to 5, and sigma C is given as 250. Now when I solve this, I get LE to be greater than equal to 3847.5 mm, which means I can take LE as 3847.5 mm from here. Now I need to calculate the actual length L, for which it is given that LE is L by root 2. So when I substitute, I get the value of L as 5.441 meter. So this is the minimum actual length of the column to satisfy the Euler's formula. I hope you have understood the numerical. We'll continue with some more concepts of Rankine formula in the next class. See you in the next session. Thank you.